Second order derivative, example 1. The displacement of a particle in meters at time t seconds is modeled by the function f of t. The acceleration of the particle, meters per second squared, is the second derivative of the function. Find an expression for the acceleration of the particle at time t seconds. So we've been given the function f of t equals t squared plus 2 over root of t. Whenever we are differentiating, we have to have the function y in the form of x to power n to then apply the derivative dy dx equals n, bring the n down, x to power n minus 1, and take away 1 from the exponent. And the second derivative, the 2y, the x squared, will be bring the n minus 1 down, so you got n to power n minus 1, you got n minus 1, x to power n minus 2, and take 1 from the exponent. So that's the format we have to apply. We have to make sure the function f of t will be in this format. So to change the function f of t, so f of t will now be t squared over root t plus 2 over root t, since they have the same denominator. And that will be, now we know what root of t is. Root of t is t to power a half, and 1 over root of t will be t to power minus a half. So that's what we're going to apply here. So that will be t squared, t to power minus a half, plus 2 t to power minus a half. And that will be equal to 2 minus a half is 3 over 2. So that will be t to power 3 over 2 plus 2 t to power minus a half. So this is f of t now. We have to differentiate it term by term. To do the second derivative from this, so we get f dash dash t equals, well, n is 3 over 2, so we got 3 over 2, and then 3 over 2 minus 1, that will be a half, times a half, t, because x is t in this case, then 3 over 2 minus 2, so that will be 2 power a half, because 3 over 2 minus 2 will be minus a half, plus second derivative for this one too. We got the 2 there. We're going to bring n down. N is minus a half, so times minus a half. And then we take 1 away from that. Minus a half, take away 1 is minus 3 over 2. Then t minus a half minus 2 is minus 5 over 2. We know how to work that out. Minus a half minus 2 over 1, because minus 2 is 2 over 1. Multiply that by 2, multiply that by 2. So that will be 2, 4. So that will be minus 5 over 2. That's how we get that. And then we can simplify this. Now we're going to use this relationship here. So that one here would be 3 times 1. So that would be 3 over 4 times 1 over root of t, right? Because that's 1 over root of t. Plus minus, well, 2 we cancel 2. Minus 1 times minus 3 over 2 plus 3 over 2 times. Now, if we have t power minus 5 over 2, and that can be written as t minus a half to the power half all to the power of 5, because 5 times minus a half is minus 5 over 2. And that would be, well, we know that t to the power minus a half is 1 over root t, so that would be 1 over root t to the power 5. And that would be, well, 1 to the power 5 is 1, so that's 1 over root of t to the power 5. So that's using indices there. So this will be 1 over root of t all to the power 5. And to continue to simplify this, that's 3 times 1, so that would be 3 over 4 root of t plus, now that's 3 times 1, so that would be 3 over 2 root of t all to the power 5 here. And that's the second derivative here. And that second derivative is the acceleration. Acceleration is the derivative of, second derivative of displacement over dt squared. And that is what we just done. If s equals displacement. So we have to differentiate displacement twice. The reason for that is because velocity will be changing displacement over changing time. To get acceleration, so acceleration is changing velocity over changing time. And if I'm replacing my v, which is ds dt, as you can see, if I'm replacing that, v equals ds over dt, and for my a, which is dv over dt, therefore I'm going to change my v now, so the operator d dt operating on ds dt, which is the velocity, and that will be d squared times the s over dt squared. dt times dt is dt squared. D times d is d squared, and that's the s here, still the displacement, and this is s. So that's what s is. S is the ft. So the answer is that. So this is what is expected of us to do. So f dash dash t, which is the acceleration, as we've explained, we differentiate it twice, equals 3 over 4 root of t plus 3 over 2 root of t all to the power 5. So that's the expression that was required.